Hi, everyone. We're going to go ahead and get started. Thanks again to everyone for joining us. This is our second episode of our Graph Gurus webinar series for developers. And today's topic is building a next generation recommendation engine with a graph database using TigerGraph. My name is Emily McAuliffe, and I will be helping moderate the webinar today. Before we get started, we have a few housekeeping items. So all attendees are muted right now. If you need to reach us via, you can use the chat feature in Zoom. And at the end, we will have a 10-minute Q&A. So you can send your questions at any time using the Q&A tab in the Zoom menu. And we're also recording this webinar, so if you have to drop off, you can look for that recording in your email probably tomorrow. And a link to the presentation and reproducible steps will be emailed also. And if you want to download the developer edition right now, you can. It just takes a minute or so to get the email. So we're going to start by introducing our moderator today. And Victor Lee is our Director of Product Management, and you can see he has an extensive background in computer science and technology with a PhD in graph data mining. So I'm going to go ahead and pass it off to Victor to introduce himself and our other speakers.
Thank you very much, Emily. I'm glad to be here again for another one of TigerGraph's webinars. This is the second in our Graph Guru series, and last time our initial topic was I believe our biggest webinar attendance ever. So we hope that we are able to deliver to you information that really is helpful to you to understand how Graph can help solve some of your problems. Joining me today is Ranchu Sung, who is one of our engineering managers. I've had the pleasure of working with Ranchu for over 3 years. He has an excellent educational background, including a master's degree in computer science from Cornell. He is one of the co-authors of the GSQL language, and importantly, he is the one who led the development and design of GraphStudio, the graphical user interface for TigerGraph that makes it easy to go through the entire design cycle of not just visualizing graphs, but designing your graph solution. So we're going to move right into the topic. So the topic today is building a recommendation engine. Everybody in all sorts of businesses can benefit from a recommendation engine. So we're going to show you how you can do that with a graph if you haven't seen that before, and with TigerGraph in particular. Ranchu is going to go through the various phases listed here. Again, the GraphStudio interface can be used for all these different phases, 1 through 5. And then at 6, once you've developed a solution, you can also run a query through a RESTful endpoint. And again, there at the bottom is the download link where you can download the developer edition of the TigerGraph platform. If you haven't already done so, I guess probably you should wait till after the webinar, and then you can go back and follow along and see what we did. All the files that we use will also be made available. So with that, I'm going to turn over the presentation to Ranchu and let him demonstrate for you our recommendation engine. Ranchu?
Okay. Hi, everyone. This is Ranchu Song from TigerGraph. Today, I will demonstrate how GraphStudio makes it simple to design a recommendation system from start to finish. We will break it down into these 6 basic steps. From a graph perspective, the design will be fairly simple in order to make sure everyone can follow along in our limited time. At the end, we will discuss a couple of ways that this could be extended for more sophisticated recommendations. Today, we will use the movie length 20M dataset. This is the largest movie rating dataset of movie length dataset series. But for TigerGraph, the data scale is still pretty small. The dataset contains over 800 megabytes in its raw format, which contains 20 million ratings from 138,000 users towards 27,000 movies. You can download the dataset from this link. Now let's take a look at the format of the dataset. All the data files are in CSV format. We will use these two data files, movies.csv and ratings.csv, to build our movie recommendation engine. Here we show the first several rows of the two files, and annotate the different columns of the files in different colors. First, let's look at the movies.csv file. Each row in this file represents one movie. The movie has an ID, a title, and a bar character concatenated genres. The data delimiter is comma, and it uses double quote character to enclose the title column in case the title contains commas, like the movie with ID 11, which is American President, the 1995. You can see there is a comma within the title. Each row in ratings.csv represents one user rating towards one movie. The rating is a double number, and it has the lowest number of 0.5 and the highest number of 5, same as most common rating platforms. The timestamp is an integer representing the Unix epoch timestamp. The dataset doesn't have any user identity information. Now let's create the graph schema for this model. In this movie rating model, the schema should contain two vertex types, person and movie, and one directed edge type, rate, starting from the person vertex type and target at movie vertex type. Now let's switch to GraphStudio and go to the design schema page to create this schema. First, let's create the person vertex type. It should contain a primary ID and no attributes. We can choose an icon for this vertex type. Let's choose this one. Then let's create the movie vertex type. We can choose an icon for it. The movie vertex type contains two attributes. One is title, another is genres. Both of them are string type attributes. Then let's create the rate edge type. Click this button, click person, and click movie. This edge type should be directed. It contains two attributes. One is rating, which is a double attribute, and another is the timestamp. Since timestamp is a reserved word in TigerGraph, so we use another name, rated at, and the type is data time. Okay, so now let's publish the schema. Publishing the schema will take about 1 minute. Let's make use of the time to look at the next step. So after we create the graph schema, the next step is loading data into the graph. Now we have our data sources, which are the CSV files of the movie list dataset. We also have the graph schema. We need to define the mapping between them. In ETL, this procedure is called data mapping. In our case, the mapping is straightforward. As of mapping from the movies.csv to movie vertex type, the movie ID column is mapped to the primary ID. The title column is mapped to the title attribute, and the genres column is mapped to genres attribute. When loading the data to the graph, each row in movies.csv will create one movie vertex. For the mapping from ratings.csv to rate edge type, the user ID column is mapped to a person vertex primary ID, and the movie ID column is mapped to a movie vertex primary ID. For example, like the first row of ratings.csv, it creates one edge from a person vertex with ID 1 to a movie vertex with ID 2, which is this Jumanji 1995 movie. And the edge will have an attribute rating 3.5 and the timestamp values this number. Same for all other rows. We don't need to create a separate mapping from this ratings.csv to person vertex type because when we load the edge data, if the source vertex or target vertex of an edge doesn't exist in the graph, TigerGraph platform will automatically create that vertex with all attributes having their default values. Now let's create data mapping in GraphStudio. We switch to the Map Data to Graph page and click this button to add data sources. We have already uploaded these two CSV files in our server. First, let's add this ratings.csv. GraphStudio will smartly analyze the file and provide options of how to parse the file. If the options are not correct, you can also manually change them, and the parsing will be updated in real time. Click Add button, and this file is added to the working panel. It will show as a file icon. Now let's add the movies.csv. Recall we mentioned before that the title is enclosed by double quote if it contains commas. So here we select double quote as our enclosing character. Then click this Add. Now let's map movies.csv to movie vertex type. We drag it here, click this button, click movies.csv, and click movie vertex type. In the right working panel, two tables appear. Left table represents movies.csv, and the right table represents the movie vertex type. We use mouse clicks to build the data mapping. Then we map the ratings.csv to the rate edge type using similar steps. Well done. Now let's publish the data mapping. Good. Now we can load the data to graph. Switch to load data, this load data page, and click this start loading button, then click continue. So after the data loading starts, on each file icon, you can see current loading progress. And on the right side, you can see the graph size is rapidly increasing. It will only take around 2 minutes to load the whole data set, even on this virtual machine of my laptop. TigerGraph is a real-time graph database, which means you don't need to wait until the data loading finish to use it. We can directly switch to this Explore Graph page and play with the partial data we already loaded. Let's first pick 5 movie vertices and the person vertices. You can double-click one vertex, and it will expand to up to 200 neighbor vertices. In GraphStudio, we provide commonly used graph exploration functionalities. You can switch them from this left side tabs. Like the second tab is the multi-hop customizable expansion. The third one is shortest passes. And the fourth one is finding the connections between multiple vertices. We are working on providing more in the future. And in the right-hand side panel, on the toolbar, you can use these 4 buttons to visually edit your graph data, like add and drop vertex and edges, edit the attributes. Because of time limitation, we don't demo these features today. Now let's go back to check how is the data loading going. Oh, it's already finished. So you can see that we have loaded 165,000 vertices and 40 million edges in the graph in just 2 minutes. This is only on the virtual machine of my personal laptop. So TigerGraph's data loading leverages MPP technologies that can truly scale up and scale out. Imagine how fast data loading speed you can get if you are on a much powerful cluster. Now let's move to the most exciting part, implementing the movie recommendation algorithm. Let's switch to this Write Queries page and click this button to create a new query. We can name it Recommend Movies and click Create. So GraphStudio generates this empty query template for us. GraphStudio provides GSQL syntax highlight, autocomplete, and the syntax arrow and warning markers, just like other IDE does. It will be really helpful for developers.
Sorry, before you get too far, I think we wanted to show our audience what algorithm we were going to implement. And I think you did a great job of showing the data loading and the schema creation. I think it's wonderful. We can do all that in GraphStudio. I think we want to switch back to the slides just briefly to show you what is the algorithm we're going to implement.
Okay, sure. So let's hand over to Victor to give a high-level introduction about the movie recommendation.
Right. So, of course, there are many different recommendation algorithms out there. We're going to do one of the most basic and well-known, collaborative filtering. And the reason why we're going to do that one is so that those of you who are familiar with it already but haven't seen it done with a graph can see how you do it in a graph. So it's basically the implementation of this idea. People who liked items which you like also liked these other items, and those other items become the recommendation. So for example, if I liked the movies Wonder Woman and Lady Bird, we look for, well, who else also liked those movies? And then what additional movies did they like? So maybe they also liked The Shape of Water. And so that becomes a recommendation to me. The system will say, hey, have you seen The Shape of Water? Maybe you would like to watch it. So that's, and you can see what I've drawn there is actually a simple graph with two types of entities, persons and movies, which is exactly the model that we have for our data. And that's exactly, we have ratings, not just likes. So we have floating point values, so we can actually come up with a weighted score. So not just like or dislike, but we can make it a little more fine-tuned. And that's what Runchu is going to do. He's going to show you a more sophisticated algorithm that takes those weights into account to come up with a more finessed recommendation. So thank you for letting me interrupt for a minute. And I'm going to now let Runchu go back to his query writing.
Okay. So because of the time limitation, we first directly copy-paste the whole query here. And in the remaining of this webinar, I will explain the algorithm in detail. If you are interested, you can watch our video on YouTube recording how the query is written line by line in GraphStudio. Now we save and publish the query. Installing and optimizing the query will take around 1 minute. Let's go back to our slides. Okay, so let me introduce the movie recommendation algorithm in detail. The algorithm's input is a person, P, and two integer parameters, K1 and K2. Don't worry about K1 and K2, I'm explaining them right now. The output of the algorithm is at most K2 movies to be recommended to person P. The algorithm contains these 5 steps. The first step is finding all the movies that P has rated. The second step is finding all the persons rated at least one same movie as P. The third step is based on the movie ratings both P and the other person give commonly, we find the K1 persons that have most similar tastes with P. The fourth step is finding all the movies that this K1 persons rated, but P has not rated yet. And as the last step, we recommend the top K2 movies with the highest average ratings given by the K1 persons. As you can see, this is a classic collaborative filtering algorithm. In order to understand the GSQL query we have written, let's recall two GSQL concepts. First is the graph computation unit, the edge block, which basically traverses from a set of vertices following their outgoing edges towards another set of vertices. Another important concept in GSQL is accumulator, which is the runtime variables bound to each vertex in the graph, and it can carry computation results. You can watch our previous GSQL webinar at this link, which show you more details. So here, we use this example to explain the meaning of each clause in an edge block and the use of accumulators. In this example, we are calculating the average ratings of the movies given a set of persons. So we have defined an average accumulator AVG rating. Assume that the previous computation already selected a set of person vertices, Tom, Emily, and Dan. Now we have this edge block. The first line of the block indicates which side of the vertices to select. You can select either the left side or right side of the vertices. Here we are selecting the right side, which are the movie vertices. The second line indicates the whole traversal, which starts from the vertex set named people, and going through the right edges and reach all movie vertices it can in the graph. Here, S, R, and M are aliases of the three parts of the traversal. Now you get this whole subgraph. It contains 7 triplets derived by the 7 edges. Each triplet contains 1 edge and its source and target vertex. The third line is where clause, which can be used to filter out some of the triplets that doesn't satisfy the condition. Here we filter out the triplet whose R.rating is smaller than 1. So the triplet Emily give a rating 0.5 to Dunkirk is filtered out. The fourth line is accum clause. In this clause, you can do calculations and update accumulators. You can update accumulator in either left side vertex or right side vertex. The calculation will happen once on each triplet, which means if multiple triplets refer to same left side or right side vertex, then the calculation will be accumulated. That's how the accumulator gets its name from. So in this example, we can see the AVG accumulator of on the movie vertex, the matrix, is accumulated twice. One from the triplet Tom rate the matrix, and the other one from Emily rate the matrix. And the red bold part shows the calculation result of the accum clause. In the fifth line is the post-accum clause, which can be used to further update the accumulator values of each vertex in the subgraph. Note that each vertex cannot refer to information on edge or on the other side vertex of the triplet it involved in this stage. Here, we just increase 1 to the AVG rating value of the movie vertices. Each vertex is calculated exactly once. And the last 2 lines, we order the right side vertices, which is the site we are selecting. And the order is in descending order of the AVG ratings. We choose the top 2 vertices, which are the matrix and the Star Wars. These 2 vertices are our final results of the AVG movie rating vertex set. Now the edge block is completed. Note that after each edge block, the accumulator values bound to all the vertices won't be reset. So the following blocks, you can use these values to facilitate your computation. Now let's have a side-by-side explanation between the slides and the query in GraphStudio. Okay. So step 1 is finding all movies that P has rated. So here we first define a P set, which contains only one vertex, person vertex P. Then we use an edge block to traverse from P set through the rate edges and towards movie vertices. We select the right-hand side vertices, which are the movies. And we also use an accumulator called rated to annotate that this movie has already been rated by P. So later we won't recommend this movie again. We also have a rating by P accumulator here to record the rating score on the movie vertex. So later it can be used to calculate the taste similarity. In the second step, we find all the persons that have rated at least one movie that P has rated. So in this second traversal block, we start from P rated movies vertex set, follow the reverse rate edge, and reach all the person vertices. Here in the where clause, we make sure that we don't traverse back to P. We call this vertex set people rated same movies. Imagine how difficult it will be to implement this logic in relational database. But in graph, it's this simple. Step 3 is finding the K1 persons that have most similar tastes with P. Here we use the cosine similarity. This is the cosine similarity formula. Given two vectors that have the same dimensions, their cosine similarity is the dot product of the two vectors divided by the multiplication of their lengths. In our case, given person P and one person in the people rated same movies vertex set, vector A is the rating P give to the movies these two persons both rated, and vector B is the ratings the other person give to those movies. So we use here we define 3 double sum accumulators, which is length A square, length B square, and the dot product AB, which represents the square of the length of vector A, square of length of vector B, and the dot product of A and B, respectively. And then we have the fourth double sum accumulator, cosine similarity, which leverages these above 3 numbers to calculate the cosine similarity. So back to the subgraph in the example. If the ratings are as annotated on the edges here, in the right-hand side, the cosine similarity will have these values. In this query block, in the accum clause, we use these three statements to calculate the length, the square of length A, square of length B, and the dot product of A and B, respectively. Then, in the post-accum clause, in the right-hand vertex, we can leverage the accumulated 3 values to calculate its cosine similarity. After we have calculated the cosine similarity of all these persons, we can order them by the descending order of the cosine similarity and choose the top K1 persons. In step 4, we find all the movies that these K1 persons rated, but the P has not rated. So in this third edge block, we start from this people rated same movies vertex set, going along the rate edge type towards the movie vertices. And in the where clause, we filter out those movies that have a rated flag as true, which means that P has already rated those movies. So we don't recommend them anymore. And at the last step, we use an average accumulator, we define as the recommended score to accumulate the average rating score that this K1 persons give to these movies. So here we accumulate the recommended score by the rating on the edge, and we order by the recommended score in the descending order, and we select the top K2 movies. Okay, now the algorithm is complete. We just print the movies we are recommending to the person P. Let's try to run the query. Here we randomly choose a person ID, for example, 61. And we give the parameters of K1 and K2. For example, we can give 30 to K1 and 5 to K2. And the TigerGraph executed the query and recommend us the 5 movies that will be recommended to the person with an ID 61. Let's show their titles. Now we can see which movies are recommended to this 61 person. And you can click this button to get the JSON output of the GSQL query. So this is the original result returned by TigerGraph. And installed GSQL queries can be accessed by RESTful endpoints so that they can be integrated with downstream applications. This is the URL that can be executed in the terminal. So let's try to run that. We change the machine IP to be the server. And here you can see that it gives the JSON result. Okay, so that's all for building the simple movie recommendation engine. Now I will hand over the webinar to Victor.
Well, thank you so much, Ranshu. That was a very detailed presentation. I know it was a lot of detail for people to follow. If you're not that familiar with GSQL, I'm sure you're going to want to go back and watch the recording. It would not have looked that complicated if we had not done the cosine similarity function. About half of the code there was due to the particular similarity function. The general idea of collaborative filtering can actually be implemented much more straightforwardly. In fact, we have an example of that in our online documentation. There's a document called GSQL Demo Examples, which there's a video recommendation system, which is basically the same as movies. And it not only looks at which movies you have watched, but it also looks at the genre of the movies. If you recall the data set back at the beginning, in the information that we have in the data set, it lists the genres of the movies. So that can be extracted and treated as a separate piece of information. And so for that example, we actually have a more complex schema. So I'd invite you to take a look at that. Of course, there are many other possibilities for recommendation, including looking at the users, profiling the users so you can do more personalized recommendation. So you can blend Customer 360 with the product content-based analysis to do even better recommendations. And of course, there are other scoring systems. We have production examples of TigerGraph being used. In particular, Wish.com is delivering real-time recommendations for cross-selling and upselling to their customer base of over 300 million users, doing this in real time, which is helping, it has helped them increase their revenue significantly, and they are a multi-billion-dollar business. So thank you. We're looking to see if there are any, if you have any questions, please submit them because we are now available to take your questions. If there's some information on the next slide to remind you how you can submit a question, either through the Q&A on your Zoom panel, or we are also checking the chat.
Yeah,
so
there's
let me
questions in chat, Victor.
Yeah. Okay, so question, is there any guided training with some sample data? I can actually answer that one. So first of all, for this example, we will be providing these scripts and data. The document that I referred to in the previous slide, GSQL demo examples, when you download our developer package, it will include on there files for some examples that we have. So we have documented training examples, GSQL 101, and also the GSQL demo examples. Both have example files that you can download and even follow along with videos. Are there any other questions? Let's see, there was one. Okay, Renshu, if you could, can you show the GSQL code again of the query?
Sure.
We had a detailed question from somebody who knows a little bit about GSQL, but was asking about the syntax.
Yeah.
They asked in that first block, why is it that you can use m dot at rated equals true instead of plus equals true? And maybe you can explain the difference between equals and plus equals.
Actually, that's a very good question. So in the accum clause, the accumulators support both equal to operator and the plus equal to operator. For the plus equal to operator, as I explained in the webinar, it will take the accumulation semantic, which means that multiple triplets towards referring to the same vertex, all the calculation will be accumulated. And in the equal to operation, this takes the assignment semantic, which means that the right side value will be assigned to this accumulator. So if there are multiple triplets referring to the same vertex, the result will be undeterministic, which because in a multi-thread environment, it's not guaranteed which value will be assigned finally to this accumulator. But in this particular case, because from the P vertex towards the movie vertices, each movie is rated only once by this person P. So the assignment, the result is deterministic. And all the movies will be assigned exactly once to the rated accumulator value as true. Same for the rating by P accumulator.
Right, and that again, that works because in this example, we're only looking at one user, so there's only one set of ratings. If we had multiple users and we were accumulating, like I believe if you look at the later blocks, we are looking at multiple movies, multiple users, and so there for the accumulation, we want to use plus equals.
Yes.
Thank you. Any more questions?
There's a question in the Q&A.
About, is there a recording of customer 360 view? We have on our, we have something called Test Drive, which is how you can try online a system that's already running, so you don't have to install it on your server. We have several different use cases there. One of them we call Social Graph, so it's similar to a Customer 360, so it's already live and running and with queries. And there is a video that goes along with that. So each of the test drive cases, if you just go to, it's on our main website. I think it's Try It Now or Test Drive. I forget the exact name, but it's from our main website. One click will get you there, and there are a set of videos that go along with each of those use cases. Let's see. There was another question which I tried to follow up with online already. It was like it's requiring some clarification. Oh, we have some more. Let me see.
Yeah.
If
your network has
if your network has only one type of vertex, do you still need a schema? Ranchu?
Yes. So in TigerGraph, we are a schema for graph database, which means you need to first define your graph schema. Then you can build the business logic based on that. However, in TigerGraph, we support the online dynamic schema change. So if your business logic changed over time, you can change your schema accordingly.
Sure, and I would just point out when you say one vertex type, so let's say you have a social graph, you have persons, everybody's a person, but you have connections. So you have to specify what is the type of your connection. So maybe you have only one type, friendship, that's fine. So you have one vertex type and one edge type, and you show that by a loop, a self loop. The edge goes from the vertex back to the same vertex.
Yeah.
And another question, you seem to be running on a Mac OS, but this is not on the list of certified operating systems. How is that the case?
Actually, this is my Chrome browser on Mac OS, but actually it's connecting to my Linux server at this IP. So actually,
right.
you're running on the Ubuntu Linux system.
Right. So we actually are running on Ubuntu either through a virtual shell, a remote shell, or I have a virtual machine installed on my Mac. So it is Linux. We currently support Linux systems. And let's see, are you using a browser with, yes, I think we answered that one. And somebody asked if could we do protein interaction for an example. Sure, we could. I actually did a little protein interaction in examples. You know, during my graduate school days, I did protein-to-protein interaction networks. You know, we don't have one ready today, but we'll take that as a suggestion for another demo example in the future. And a couple more. Let's see. I think that's all the questions. So if there are any more, please you can send them to us. Can you go to the last slide again? You can contact us several ways. So we do have one more Graph Guru webinar planned already. It will be on September 12th on detecting fraud and money laundering, and we will have more. We're talking about number 4 and 5 already. So please check up with us. And if you have any additional questions, there are several ways to contact us. You can do info@tigergraph.com. You can download the Developer Edition and try things out for yourselves. You can see where you can get the Guru scripts. Please join one of our discussion forums. We're on Twitter, Facebook, YouTube, LinkedIn. So we'd be happy to hear from you. And any final words from you, Emily?
No, I mean, we did have one more question. I don't. We have like 1 more minute. So, but it's in the chat, and it's about how can I integrate a visualization tool with TigerGraph.
Sure. There are a couple different visualization tools which already are been demonstrated to connect to TigerGraph. We have a simple REST API interface. So, and we also have a JDBC interface. So any tool that can use JDBC or a REST API potentially can connect to TigerGraph. And we'll be making some specific announcements in the next several weeks. But there's certainly we're certainly able to connect. I want to thank Ranchu again for his great presentation today. I think you did an excellent job, and thank our audience for joining us. And please stay tuned for our next one on anti-fraud and anti-money laundering.
Thanks, everyone.